Good morning and welcome to day 2. So today it's QEMU. Yesterday we had a nice keynote about KVM and how KVM evolved during the last year, since we did KVM from 2014. Now we're going to talk about how QEMU evolved. So the biggest thing that we have on the QEMU side is we are now part of a conservancy, we have an entity. We finally, if you haven't read the news, we can now do lawsuits. It's the best thing ever. No, honestly, the major reason we joined them was so we can get funds. Before that, we were always struggling. We had Summer of Code coming up every year. Google wanted to give us money. We were like, sorry, we can't take money. Can you just give it somewhere else? Like the Tor Foundation? And so we basically gave away all of the money we received, whereas now we can actually make use of it and can fund people to come over here and to do fancy things. So it's a really good step forward. There were a lot more things happening throughout the last year, though. We were actually able to release 3 different versions of QEMU just within the last year. There's 2.2, 2.3, and 2.4 getting released, which is really, that's a lot of releases. And in those, we had a lot of really cool features. I just picked a few that looked like totally outstanding. We have ACPI support and PCI support on ARM now, which is novel. A new VirtIO VGA adapter, which basically sets the groundwork to finally get 3D support in virtual machines with power virtualization. We have a lot of groundwork that got done and that is still work in progress, and hopefully by KVM from 2016 you will see real good results of multi-threaded TCG. So if you're emulating a machine, you could run it on multiple host CPUs as well in parallel if the guest sees multiple CPUs, which is very impressive work. People have been talking about it for about 10 years now. Finally, we're getting to it. If you look through the commit logs, oh my God, there's a lot of MIPS in there. So apparently somebody at Imagination figured, QEMU is a cool project to contribute to, let's just do it. And now every single release, we have new machine types, new CPU types, new features coming in. They're doing a lot of work. And of course, we have a new core, tri-core. I guess nobody's using that one, so. We also have, like every year, Google Summer of Code. If you're participating, congratulations. If you're not, please do so next year. We do need more projects. So this year around, we have 3 big projects that happened during Summer of Code. They're still ongoing. The Summer of Code period hasn't ended yet. So we have macOS 9 PowerPC support that Cormac is implementing. That's going pretty well. We have a project to finally merge the SUSE CD-ROM emulation and the Atapi CD-ROM emulation into one piece of code. Today, if you're using a SUSE adapter, you're using different code than if you're using an IDE CD-ROM, which under the hood would actually be the same thing. So we're finally merging those code paths. That's Alex's project. And then if you've ever used audio in QEMU, you've probably realized that it's completely different from any other subsystem. Not only in coding style, but also in how it works and how you use it. You use environment variables rather than command line switches. It's very, very, very special. So Zoltan is cleaning all of that up and is doing really good work with Gert on it. So thanks for all the Summer of Code contributors. Thanks to all the Summer of Code work that's been going on. It's been very, very useful, and I hope I'm going to see a lot more and cool projects next year. We're also hosting libvirt projects, but since we're having a libvirt keynote tomorrow, I'm not mentioning those. But I guess the thing you're most eager to see is how did we evolve during the last year? How much did QEMU grow? And I can tell you, it did grow. We are almost at 1.6 million lines of code now, which is massive. We are a really big project by now. There's a lot of stuff going on. You can see during the last year, we did shrink on the number of commits slightly, and the lines added as well, but that doesn't mean that we don't grow, right? We're still growing a lot as a project overall. What I find very, very, very impressive, however, is the review rate So back in the beginning, in the early days of QEMU, there was a lot of code that got added, and nobody reviewed it. Until a couple of years ago, when we finally switched to a more Linux-like workflow where you are doing sign-offs and you do sub-maintainers and people review code in peers. And ever since then, you've seen a really nice take-up on reviews. So by now, we're actually almost at a level where most of the code that gets in gets reviewed by somebody else in parallel to just the maintainer, which is very, very important if you want to have a high-quality product out there. If you take a look at the individual targets, if you look at the lines of code added, you can see that hardware models are basically averaging out. So we're getting new hardware models, we're getting changes in hardware models, but this is about the level that we hit where there's just not too much churn coming in, there's not too much novel hardware coming in, and new hardware is usually pretty simple too. The Linux user target is, I guess if you see that line, you would say it's stable now. If you've ever used Linux user, it's never going to be either way. We have changes, we still see code going in, but it's not a lot of churn, which means you can probably use it for most use cases and whatever people use it for. It's good enough by now. You don't see a lot of code in there. The target directories, however, you've seen a really big spike there. So does anybody have a nice guess on what is actually contributing to the increase in target directory usage and target directory commits? All right, we'll get to it. So let's take a look at the lines of code added by directory. All right, we did that one. Of lines of code added by directory throughout the time. So this is sorted by the total number of lines of codes added. You can see that ARM over there, that was when 64-bit ARM support came in. The spike to the, yeah. By now, we're basically down to normal again. So ARM is an actively supported, actively maintained code base where you always get new code in, you always have some stuff going on. It's actually one of the nicest targets we have. PowerPC is very similar. You can see that the spike up there to the 9,000 almost, that was when Tom was around and implemented a lot of new Power 8 features. Power 8 is out, there's only so much more you can add, so right now it's died down again. But there's code changes across the line throughout. MIPS is massive. You see that spike going up on MIPS? That's when the guys came in and said, we want to contribute. And that's why you saw so many MIPS changes during the last year. If you look at the smaller targets, x86, well, Fabrice did it, and then it was done. Pretty much, just like always when Fabrice takes things. SU90 is pretty similar. You basically have the spike when support came in, and ever since then it's kind of maintained. It's still we are still working on it. Tricore has a lot of lines of code added, but do you have any guess what this line is going to look like tomorrow? It's going to look like any other line over here. So if you look at Spark, Extensor, Chris, all the Leaf architectures, they basically had somebody committing code and then it died down. And the leafer you get, the less changes you receive. So basically you have alpha that is actually getting maintained. You see the negative numbers there. That's because Widget is just cleaning up the code. 68K has died down, SH4 has died down, Microblaze has died down, OpenRISC has died down, Unicore is basically committed and never looked at it again. LM32 has at least some contributions to it. Moxie is one commit and that's it, done again. That's just the way it goes when you have all of these soft cores that you want to implement as an experiment. Experiment works, or the code is good enough, things don't change in the architecture. And now we just live with them. But keep that in mind if you ever want to contribute a new architecture, try to keep it alive, because we're going to be stuck with it. So who's contributing to all this code? Well, we have, as always, Red Hat as number one on who is writing patches. But the top three have changed quite a bit. So number two by now is Linaro, who've done a lot of really, really significant work in QEMU in the last year. And what I'm really happy about is number three, the individuals. So people who I could not affiliate with any company at all, not even, this doesn't even mention smaller companies. Like we also have a lot of, like a really long tail where we have a lot of small companies contributing. This is where there's no chance to tell whether this is a company at all. It's just individuals who do random things. University students, just somebody in the open doing open source work because they like it. This is an awesome number. So we have about a fourth of our commits come from individuals, which is really nice. If you look at the committers, you see basically about the same level. We have Red Hat as number 1, Linaro number 2, and individuals who maintain subtrees just because they like to do it on their free time. It's nice. We have but however, one thing, the thing that I mentioned earlier, which is what I'm really mostly happy about, is all the reviews. And you can definitely tell that Red Hat has a company culture where they basically encourage people to review code. Whereas we don't. Down there, SUSE? Oh well. But fair enough. There is a lot of review going on, and compared to the number of commits and the number of authored patches from people, it makes a lot of sense that Red Hat also reviews most. But this is going to be the awesome part now. So I would like to have Peter, Paulo, and Marcus stand up. Thank you, guys. You were the top 3 authors of patches this year. So Marcus, you can sit down. Stefan gets up. You guys committed the most patches last year as your own trees. And now Peter can go down, and Stefan can, and Eric and Michael should go up. Where's Michael? I don't see Michael. I guess he's just still asleep. Those guys reviewed way more code than anyone now. Look at those numbers. This is gorgeous. Thank you, guys. And thanks, Paulo, for being in all 3. So with that, happy hacking and enjoy QEMU.
Thank you.